All right. I'm here with Pete LeVasseur, who leads the Safety-Critical Rust Consortium. So, Pete, I think people have probably heard the term safety critical by now. They might think maybe it has something to do with like planes or cars or something like that. But first of all, what is safety critical software, and how does it differ from just regular software?
Yeah. I mean, I've had this conversation come up with talking with folks that are in the Rust community and kind of being a little bit of an ambassador or bridge, for what does safety critical mean. So safety critical, though, at the end of the day is fairly simple. A safety critical system is one that has an impact or could have a potential impact on the health of humans, an impact on human life, an impact on the environment, or have potential negative consequence to property and real things in the world. So it's kind of things that so software that could go on a system, on hardware that could have some impact in the world that could be negative in some fashion is, I guess, what you might call safety critical systems or safety critical software. So it entails some additional thoughts around, therefore, sort of how to write the software, design the software, and there's some regulations and these sorts of things that go into it.
And are there different regulations for different kinds of safety critical software? Are there different tiers?
Yeah. So it tends to be that you have these different safety critical industries. So you might have like aerospace, so things like airplanes and satellites and these sorts of things. You have automotive, cars, things that are on roadways, medical devices. So there's a wide range of different industries. They tend to tie back to some fundamental documents for inspiration and tend to kind of have their own flavor on top of that for sort of what goes into those industries and what sort of matters to those industries. So there's sort of many different industries, many different potential regulations. They tend to have some through lines, but you need to be aware of what the differences are between them.
And what was your first introduction to safety critical?
My introduction to safety critical was wrapping up school and thinking I want to do software. I've been a software writing enjoyer, and I was interested actually in mainframes at first. So mainframes, assembly on mainframes. And I did an internship at a company that did this kind of work, and they built tools to help other developers writing assembly for mainframes. And then there was, an attempted hostile takeover of that company, and they froze hiring. And so I said, okay, I'm in Metro Detroit. There's a lot of automotive. Let's kind of see what's out there. And so my first real touch point with safety critical is in the automotive space. And in particular, I spent around 10 years or so working in the space of automated driving / advanced driver assistance systems, or ADAS. And so you might think of those systems as being like the underlying technology for things like Waymo and things like lane keep assist. So really more in the space of kind of algorithm development for automated driving and ADAS was kind of my first touch point with safety critical.
So a lot of people listening to this will probably have no trouble being convinced that Rust is a good application, a good language for that kind of application. But it seems like kind of adoption is lagging a little bit behind. So to start off, how did you go from writing assembly for mainframes to becoming interested in this language called Rust?
I mean, I have been interested in like programming and languages and stuff like that since I was a kid, since I was younger. And I when I got into automotive, I'd spent a couple of years. I think I spent around 2 or 3 years professionally writing C and C++ in automotive at some automotive suppliers, and I sort of reached this point where, even if I knew what not to do, and if I sort of followed some rules for writing software, there was always going to be some new joiner to the team. There was always going to be somebody that needed a pull request reviewed, and I would inevitably have to be reviewing some C and C++ code, and there may be some subtle things there that if I'm reviewing the code on, say, 5-6 hours of sleep after being up with my 1-year-old, it's not, things may fall through the cracks. And so around 2017 or so, 2016, 2017, I started thinking there's got to be something out there. There's got to be some answer. Like, other people have faced issues like I am facing with double freeze, with data races. Someone else has faced these issues before, and so I had a bit of a side quest with Haskell for like 6 months or so. So this was around the time when Galois had come out with I think it was called Copilot. So it was a way to guarantee that the C code that you generate from writing in this domain-specific language in Haskell was memory safe. So it was guaranteed memory safe, and that seemed really cool. But ultimately, I was like, the folks that are writing software in automotive often don't have sort of an academic background in computer science. They are much more knowledgeable in, say, like electrical engineering topics, mechanical engineering topics, and they write software to get done what they need to. And so saying, hey, like, learn Haskell, learn this DSL, it seemed like a bit of a bridge too far. So then I think it was 2017, I probably stumbled into Rust for the first or second time and said, like, whoa, this seems like it's solving a lot of the problems that I keep running into myself and keep finding in other people's code as well when writing C and C++ in automotive. And so that's kind of where the journey began for me.
Yeah, it's interesting. You talking about, you have people who are electrical engineers, mechanical engineers. Um, what's been your experience introducing them to Rust?
Thus far, I have not had the good opportunity to introduce too many people who have this background to Rust. So thus far, I've actually primarily been interacting with maybe similar levels of language nerdery or higher than my own when it comes to folks that we're interacting with and doing Rust. But there has been some very promising things that I've heard. So working on an open source project called Eclipse uProtocol, there's an engineer from an automotive supplier that was wanting to contribute to Eclipse uProtocol, but there was a C++ sort of SDK, there was a Java SDK, there was a couple of other language SDKs, but he kind of thought Rust was the future, and he was a little bit, he had more of like a Java background, and so he was like, I don't really want to jump into C++ at this stage in his career, and he found that Rust was more approachable in that way. So he had kind of this academic background and everything with CS, computer science, but he was kind of coming at it from this other angle of like, oh, now we have to do hard real time. Oh, that's like, I don't want to do that in C++. I want to try to reach for the language that has some of these tools available and these guardrails available. So
Nice. So just probing in a little bit deeper to safety critical software, which is, I mean, it really just rolls off the tongue. I feel like I've said it like
keep saying it. It's great. It's great.
Interview. All right. So when you're writing safety critical software, what do you do differently, like in real life, than you do when you're just writing regular software?
Yeah, I mean, so because I've been in that space, it's almost a fun question to have to answer because I have to imagine what it's like to not write safety critical software.
Fair enough.
But yeah, so to maybe expand on something that I'd mentioned earlier, there's different industries and they have different standards. And so, for example, in automotive, there's a standard called ISO 26262. So this is what is the regulating document and what an assessor will look at when they're assessing your code against this standard and saying, okay, okay, I'm going to get in trouble because ISO 26262 straight up comes out and says it's not a process. Okay, but it's hinting at a process that you should follow. And there are reasons for that. It's so that because these documents are not put out every year. They're not put out every 2 years. They're put out like every 7 to 8 years. And so they need to be a little bit broad to allow for the interpretation to change as the technology changes, as the state of the art changes.
It's an idea of a process.
It's an idea of a process. Yes,
Got it.
yes. There's a waft of a process there. Yeah. But seriously, there's different levels of safety criticality that say are in ISO 26262. So you have ASIL QM, which is quality managed. Then you have ASIL A, B, C, and D. And as you walk your way down from QM to A, B, C, and then D, you get higher levels of safety criticality. And so ASIL QM might be something like your infotainment system in your car. So you're adjusting the volume, you're adjusting the temperature, all this kind of stuff. ASIL B might be something like okay, part of an ADAS system. So maybe the sensing or the perception part of the ADAS system. So there's no actuation that's happening due to it. But ADAS is Advanced Driver Assistance System. So yeah, so it's something that helps a driver perform some task in their vehicle, but it's not, like self-driving in itself. It's more like a function that's intended to help them. So that might be an example of an ASIL B system. So a camera system that's detecting, say, a pedestrian, or it's detecting a vehicle up ahead. And then an ASIL D, as in dog, system might be something that controls actuation, so a brake controller. So when a brake controller gets a signal from something like, say, the camera that says, oh, I see a vehicle up ahead, then that brake controller is directly responsible for stopping or not stopping the car, and therefore it's a higher level of safety criticality. And so the process for development is actually different depending on which level of safety criticality that you're at, and the requirements are different as well. And ISO 26262 is a somewhat expensive document, and it is copyrighted. So I won't get into all the details here, but there are some through lines. So there's having a safety qualified compiler, so a safety qualified tool chain. So if you're doing, say, normal software development, you probably don't need this. This is something that has been qualified by an assessor, an assessing body, to the degree necessary to say that the code that you write will result in the binary that is expected. And so there's some examples of this in the Rust ecosystem today that you can go out and find for a safety qualified compiler. Another aspect that's very common and needed is a set of coding guidelines. So it's not enough to just say, hey, Rust is a great language, just use it however you want because you get more safety. There are maybe ways of using it that are more or less preferential or beneficial in a safety critical context. And so having a set of coding guidelines which could help maybe tune the kind of code that's written would be beneficial in those cases.
What's an example of a guideline that helps?
So, so the goal, of part of what we're doing in the coding guidelines subcommittee of the Safety-Critical Rust Consortium is to come up with a set of coding guidelines and also corresponding Clippy lints, right? These may not go all upstream immediately because we may have to generate a lot of them, and so we may sort of live out of band for a little bit, but then slowly contribute them back upstream. There's a good chance that we would come up with a number of rules that fit into maybe like the pedantic category. So for example, we may want to have some fairly regimented limits around macros, declarative macros, procedural macros, how they're used. We may want to give, for example, guidelines about when you're writing a procedural macro, you should try to do it in a way that, should you need to during your safety certification process, you're able to actually just compile that into code and then be able to check that into your repository rather than have that live as a procedural macro that's called, depending on, again, the industry that you're doing, the level of safety criticality, because macros are still A bit of an open question when it comes to Rust and safety critical and how much to use them. They could be overused and make some of the code more challenging to understand, but there's also a good deal of voices saying that macros are actually a great way to, say, package up interactions with hardware, package up interactions with memory in a way that makes it overall a lot safer.
Is the concern that macros make code harder to understand? They make it harder to understand what's going on? Is there a concern that there might be bugs? Because I mean, a proc macro it's arbitrary code, right? Like it could be non-deterministic. Where are the main concerns coming from, or is it all of the above?
So when you say macro, people think of like C macros, okay, in like the safety critical world. And so the idea that you could even that you can use macros in a way that are safe but regimented and under control is a little bit new of a concept to the field.
Hmm.
Um,
It's not text substitution. We have
right.
uh,
Partially hygienic macros,
yeah.
expansion, and yeah, so there's all these like nice things that you get with Rust macros, but it's sort of like in general, safety critical industries are conservative. They have the potential to impact human life, and so rather than say everything is available, it's almost better. It's explicitly actually called out in ISO 26262. It's quite funny. They have like a list of requirements of what should coding guidelines be, and it basically calls out you should subset the language. You should say you shall not do this, and that's historically been the case for C and C++. We're trying to write these Rust coding guidelines in a dual manner. So subsetting somewhat, but also pointing out defects and then alternate methods to accomplish the goal that we think you might have set out to do, right? So it's not just saying, you shall not do this. It's, okay, you're trying to do this. Okay, I'm going to try to meet you where you are. Like what, like here's a bundle of different things you could try to do instead to maybe meet that need. So if you're asking specifically like what about proc macros are maybe an issue, I don't think there's a specific issue. I think it's more like it's a tool that needs to be used judiciously and responsibly, and we've not yet sort of landed on what that usage should be.
Yeah, it's one of those things where you kind of know it when you see it, if it's going over the line, but actually writing that down into rules can be difficult. Are there features of Rust that like you consider misfeatures or that you kind of wish didn't exist when you're writing safety critical code?
So features that, if they did not exist, would make life easier when writing safety critical code. Okay, so uh, okay, so I've heard stories, okay, about so in safety critical systems, in I'll speak about automotive specifically. There's a lot of emphasis put into architectural design because when you go up those levels of safety criticality from say like QM to A to B to C to D, the cost per line of code goes up. In some cases significantly, because you need to start bringing in formal verification. You need to start doing things like this to really truly prove out that what I have written will result in the system functioning as intended. So in automotive, that's called SOTIF. What is it? It's safety of the intended function, something like that. And when it comes to, okay, are there Rust features that if they were not there would make life easier? I've heard of these cases of like you have so you've architected your system such that you have like a very tiny microprocessor that's doing one single task because you need to make your safety case. You need to try to drive everything to being as low safety criticality as possible because the dollar cost of that safety critical code is so high. you end up in these weird situations where it's like you have a super like cheap processor, super cheap microcontroller that's doing something that's important, and but it's like some weird architecture, and it's something that is like maybe not supported well by Rust, right? And so one of the things that comes up is strange widths of, say, like integer types, right?
Hmm.
And so Rust, I think, is it's uniform and standard about this. So it's understood what the width of integer types, I think, generally are. Whereas one of the selling points, actually, of something like the C programming language is that it is not. And so it's possible to, say, with C, target these kinds of exotic architectures that are like very low cost. It's a very tiny microcontroller that may be like literally glued into a case that is inaccessible unless you were to, like, break things apart and get at it. I think those places are tough for Rust and may remain tough for Rust based on some earlier decisions around sort of uniformity around sizes of integers. Not to say that maybe that was a bad choice on the whole, but these are just some spaces where Rust may not find its way in the near term.
That makes sense. So if you had more flexibility in assigning like the widths of the common integer types, or maybe making new primitive integer types that have different widths, it would actually be a lot nicer.
Yeah, it could enable it to be in some of these extremely low-cost controllers in places that, yeah, are glued in and sealed shut and then never thought about again, so.
Cool. Um, so you mentioned earlier talking about you were talking about safety critical compilers, and one of the things that comes into this discussion that I've been hearing a lot about. I'm on the language team, but I think other people have been hearing about it too. Is a language specification. Um, People are working on a specification for Rust. I think some of us are still trying to decide what a specification actually means or entails. Um, First of all, have you been involved in any of that?
Yeah, I'll fully admit my bias. I'm the champion for the second half of 2025 for trying to find a path for the Rust project to maintain the FLS, which was contributed by Ferris Systems upstream into the Rust project. So
Should say FLS stands for the Ferrocene Language Specification, if I'm remembering.
yes, it used to until it got adopted by the Rust project, and now it means nothing
It's
because
just FLS.
it's just FLS, right? It's yeah, the specification formerly known as the Ferrocene language specification.
Nice. Cool.
So yeah, so I have some involvement in that space, and I show up to the T-Spec meetings, and I have a great deal of interest in making sure that um, some of the commercial entities that are benefiting, whether actively or passively, by the FLS existing and what it enables, are sort of being good stewards and are contributing upstream. And so that's what I hoped to bring to that role, sort of as champion of this goal of how do we maintain the FLS going forward. Is I said, okay, I'm leading the Safety-Critical Rust Consortium. We've got a number of different companies, from integrators to tool vendors to software vendors. They have a stake in this, and let's talk about how to make this happen. Um, so I have some stake, some bias. I'll fully admit. So if you had questions about like what does the specification mean?
Yeah, I do. I mean, one of my questions is actually what does maintaining the FLS entail? I mean, what are you mostly worried? Do you want to take this thing and just keep it at its current level of completeness and like update it as things are changing?
So what I feel like, from speaking with
What's happen and how, like w- how are you actually going to accomplish that?
so yeah, like all good things, when you eat an elephant, how do you do it? Like one bite at a time, right? So the first bite is to um, really get like some sort of smaller team together that, rather than say every 3 months, on say every third release of the stable Rust compiler, on every stable release of the Rust compiler, be able to update the FLS accordingly. Currently, the FLS is only updated on the cadence that it is due to a commercial user of the FLS that uses it to safety qualify a version of the Rust compiler. So, and their cadence is every 3 releases currently. And so what I would like to see is this to be able to be happening every release of the stable Rust compiler. From there, then you can think about, okay, how do we sort of, look at the Rust reference. In my opinion, it's a bit more of an approachable document. And so how do we take some of those aspects, maybe some of those aspects are useful for the FLS, if you're looking at it as a mere mortal and not as an assessor of safety critical software, it could be useful.
As a mortal, I can attest to that.
I've looked through the FLS. It's a document. It's a lovely document for what it's intended to do. And actually the coding guidelines that we're putting together, we gauge coverage of them based off the FLS. So we have linkage to the FLS to ensure that, we have coverage of language features. But
nice.
I think in the future, there's a whole concept around how do we have a language specification? How do we have the maybe Rust language specification? And from a safety critical background and perspective, I think it's explicitly not a goal of making a specification to allow for another compiler implementation. I think it's explicitly not a goal. However, it is in fact a very nice thing for safety critical, because there are certain instances where if you have 2 different implementations of a compiler and they are written to comply with a specification, you can then lower the burden a bit when you are shipping not compiled code, but when you're shipping source code. If you're shipping source that has been built and tested on 2 completely different implementations of a language that are implemented according to a specification, then you have to do less work. There's less dollar costs associated with shipping that software in source form. And so I have that perspective on it, where if there were, let's say, like a more holistic, more complete language specification that included some maybe greater level of formalism that allowed for another implementation, like like GCC-RS or maybe other implementations of Rust, then this could actually serve a great benefit to the safety critical community.
And how do you respond to someone who thinks, why do we really need a specification like this? I mean, we have the Rust compiler. People are using it today to write, much more reliable software than, languages that supposedly have this, I forget what you called it, but uh, uh, safety qualified compilers. Is this requirement for specification just like basically kind of like a bureaucratic checkbox of a bygone era?
Okay, I see where you're going. Yeah.
Like, look, we already have a borrow checker, we have a type system, we've got clippy lints. Like, is jumping through all these hoops actually just acting as a barrier to gaining more safety and the safety benefits that you would already get from Rust?
Regulations. Yeah. So it's a good point to talk about the liaison subcommittee that we have in the Safety-Critical Rust Consortium. We're trying to get a 4-letter word, and not the one you're thinking of, to show up in some of these regulatory documents, RUST, such that there's an indication and a clear stance made that, okay, having memory safe languages is important. Okay, having the ability to have certain checks around thread safety is important. And so we are still very early days when it comes to the liaison subcommittee, but some of the work that we're doing should help them feed and have these kinds of conversations with these regulatory bodies. Is it just theater? It is the byproduct to a degree of the very nature of what safety critical means. It is, these systems could impact and cause loss of human life. And so therefore, we as safety critical industry should have an acknowledgement that we follow some processes, we follow some known best practices. Is all of it needed? Is all of it going to go away when like Rust shows up on the scene? Things will change. I'm sure things will change when memory safety is adopted more thoroughly into these industries. I don't know that all of the sort of overhead will go away. I think there will still be very, very real economic reasons for still doing certain things. Like functional safety engineers are a vital part of a lot of these industries that are responsible for doing important work of decomposing systems. So if you have something like autonomous emergency braking, you probably don't want to spend a lot of money on doing a lot of formal verification of all of the source code. And so these functional safety engineers are in a way and in a degree very helpful for the process of decomposing systems and decomposing them in a way that you can make an argument to a safety critical software assessor that yes, we have, instead of having all the software be on one box and be written in this language for this purpose, we have distributed these functions out in such a way that the cost per line of code has gone down significantly in aggregate. So is it all theater? No, there are economic reasons for it, and there are regulatory reasons for it, and there are moral reasons for it. But will some of these things change with time, with more of a focus on these languages that offer benefits like Rust does, memory safety, type safety, thread safety? I think things will change. It's very much an evolutionary process.
Sure. Yeah, I'm not trying to bash your industry. What I am trying to do is learn more, like from the perspective of somebody who knows nothing about it. What are we actually getting for this? So, I mean, yeah, you mentioned the benefit of decomposing a system, I assume ahead of time, so that it's easier to verify.
Right.
Yeah. What about the safety qualified compiler piece or the specification piece? Or you can take you don't even have to take those examples, but I am curious about those examples of where you think it is actually adding a lot of value.
Yeah, and so that's where it comes again into like each sort of safety critical industry has their way of doing things, their own regulatory standards, but particularly for say automotive, right? When it comes to ASIL QM, I've heard arguments that so that's the least safety critical level that so it's ASIL quality managed where you don't actually need a safety qualified compiler for that level. It's really only when you go to like ASIL A, ASIL B that you start to need this. There's sort of arguments that happen in this way. Coding guidelines. There was a great document put out by Alex Celeste, contributed to it along with others earlier this year from MISRA. So MISRA, it's an organization that has these coding standards for C and C++. They've been proven to hold up in court against legal liability, against loss of life, and so they're very powerful documents for that reason. And it's a matter of these coding standards, these coding guidelines we're putting together for Rust. They will take inspiration. They will try to find where we should cover things that are not yet covered by MISRA. So, for example, that document by Alex Celeste, she went out and she looked at MISRA C and did a recategorization is what it's called. So you look at MISRA C, it's got different categories for the rules. So it's got mandatory, so you shall follow this rule no matter what. It's got required, which is, okay, you should follow this rule, but if you don't, each time you don't follow this rule, you must write down why. It's got advisory, which is, you should probably do this. If you don't do it, you just need write it at one spot and you could ignore it throughout all of your code base. And then there's disapplied, which is, this is not relevant. So what she was able to find is that around 50% of MISRA C is disapplied. She was able to recategorize it to being disapplied because of Rust's capabilities, right? The compiler, the type safety, the thread safety. So this was a huge huge impact. And seeing that and then being able to go, okay, so we only have to cover like the 50% that MISRA-C that is still categorized as being not disapplied in MISRA-C. It's like, oh, that's great. That helps us making these coding guidelines. And so, generally speaking, you'll need some coding guidelines, whether you're doing ASIL, QM, A, B, C, or D. But which rules are most important, that may change. And in reality, what happens, and MISRA gives this guidance, is that you need to have a guideline enforcement plan, and you need to have a guideline recategorization plan. And so a guideline enforcement plan is kind of what it sounds like. You've got these guidelines. How do you actually make sure that they are being applied? So this might be static analysis tools that, in the case of, say, C and C++, you need to go out and buy, you need to go out and license, and these sorts of things. And the hope is you can say, well, I ran Clippy.
Mhm.
I ran Clippy with the ISO 26262 ASIL B profile at some point in the future. And like, yep, it says I'm good. And I've written...
And the borrow checker, which is built into the compiler.
Yeah. And this also is another aspect where we can use that recategorization that Alex has put out there to point to and say, oh yeah, like that's already covered. Like we don't need to do that because of Rust the language. Yeah, and so these are just aspects that are still in flight. Again, depending on the industry, the level of safety criticality, these things may or may not be required for your particular software, project. Yeah, so guideline enforcement plans and then guideline recategorization plans, which are what it sounds like. So taking something from one categorization to another.
So, big picture, I mean, what is the overall status of writing safety critical code in Rust today? And what's the big next shoe to drop that you're working on?
Yeah, so the the cool thing about safety critical and Rust is there's a lot to do. So there's a lot of ways to get involved and to support. And even if you don't know Rust that well, if you have kind of that background in functional safety, you have kind of that background as being a systems engineer and knowing how to decompose systems. If you know ISO 26262 and DO 178 by the back of your hand, get in contact with me. We'll chat. So what I see as next steps are really identifying the gaps. We've started to identify some of the gaps and then working to close them. So in our initial several consortium-wide meetings, we identified some of those gaps and have formed subcommittees to help tackle them. You might have heard me mention them a couple times already, but the coding guidelines subcommittees, so coming up with coding guidelines, the liaison subcommittees, so talking with these regulatory bodies and helping them understand and helping us understand. And then also the tooling subcommittee, so kind of getting a broad swath of what are the tools that exist out there that could serve the needs of safety critical. And another activity of the liaison subcommittee actually is kind of road mapping out what it looks like to safety certify Rust code. And that will help us identify even more gaps. So if they say, oh yeah, by the way, when you're safety certifying Rust code, there's actually this thing that's pointed out as needed in, say, DO 178, and we currently don't have an answer to it. That's a great feedback to the tooling subcommittee so that they can sort of put out the clarion call and say, hey, there's an opportunity here if you're, if you want to do something in open source, or if you want to be doing stuff in closed source, here's a chance to help improve the state of safety critical. Today, where is it? Like, are people doing safety critical? Yes, they are. I personally know of a company that is using Rust for medical devices. So they're using it for some more like monitoring type of things, not things which would like directly interact with the patient, but for more like a monitoring application. I know, of a company that is in the aerospace kind of domain. They're using Rust. They're finding this to be still quite amenable to meeting sort of the timelines that are being requested of them while doing it in a safe and measured way. And then in automotive, ASIL QM, ASIL A, like these are kind of the domains and the levels in automotive where it's really at right now. There are some things which are expected and need to really be there for further adoption. I could go down a list of them, but a big one that comes to mind is like MCDC. So what is it? It's like modified condition decision coverage. So you folks might be familiar with like line coverage for unit tests or branch coverage. So this is kind of just a very rigorous method of testing that if I change something about this conditional, what changes in the control flow, and have I hit all of those points in my control flow as I've changed all the different criteria that goes into making a decision through this point in the software. And so there's plenty of things to still do, but I am seeing adoption kind of uptick. And particularly in automotive, there's this feeling that it's really a question of when at this point and not if. And it's coming along.
Cool. A couple things I want to peel off of that. So, you were talking about the committees and the subcommittees. I mean, is it a large community right now? Is it fairly small? Like, how many people are?
Yeah, fair. So there's around 150 individuals in the consortium. The participation in the different so there's different levels of kind of engagement, right? So if you'd like to just sort of get more of the overall feeling of what's going on with Safety Critical and Rust, you can join the consortium as an observer, and you can just get like mailing list updates. You can just like hang out in the Zulip if you want to hear a little bit about it. But if you then want to get more involved, there's these subcommittees. So for example, the Coding Guidelines Subcommittee, I think sits at around 50 members or so, with around, 10 to 15 folks pretty active and contributing. You got the Liaison Subcommittee. I think it stands at maybe around 10 members or so right now. Folks that kind of have inroads with other, regulatory things, other language things. And then the Tooling Subcommittee, I want to say stands at somewhere around 30 people or so. And so it's a pretty broad and diverse coalition of the willing to make safety critical happen for Rust. And so you've got folks, say, all the way from, say, chip vendors. So you've got folks like Infineon that are getting involved, that are pretty active members, working and contributing to, say, coding guidelines. You've got folks like AdaCore that have a Rust compiler offering that's safety qualified in there. You've got Ferris Systems in the mix. You've got all the way up to, say, aerospace companies. So you've got Airbus is involved. You have, I was looking, we have one nuclear company involved. We have a rail company involved, a couple of medical folks. And then we have, folks from automakers like Volvo Cars is there. So it's pretty wide and diverse. And I think that's what's really nice, is that the consortium was set up from the beginning to be a very welcoming place and very open place, so that if you're interested, you want to get involved, it's as simple as like, submit a GitHub issue and you're in, basically. If you can express why you want to be involved with Safety Critical and Rust, and then get involved with the subcommittees, that you're interested in, that you'd like to see grow.
Cool. The other thing I wanted to ask about, so you mentioned this MCDC coverage. I think many people have interacted with source code coverage, line-based coverage. I know about branch-based coverage, which is sort of within a line. You can see, did I short circuit, this OR condition or something like that. For someone who's trying to understand MCDC a little bit better, could you maybe give a little bit of color?
Sure. Yeah. So the way you can think about it is that you are going to permute all of the different criteria. So if you've got like a bunch of conditions ANDed together, for example, you're going to permute these things individually through their true and false combinations, and you're going to see which changes in the criteria will impact the decision. And then you will ensure that for any of those changes in the criteria which will impact that decision, that you have properly covered those in your code, in your unit tests that you write, integration tests that you write. So in that way, it's kind of like, I don't know, this very fine-grained version here where there are, let's say like in Rust where you have things like a match expression, right? When you have a match expression, there's this coverage style was not made with Rust in mind. Let's put it that way. And so when you bring MCDC to a language like Rust that has a lot of these really nice modern features that engineers really like using, there are a lot of, like, my understanding at least is, I haven't worked on it personally, but my understanding is that there are open design questions and design considerations on, like, oh, this really nice Rust language construct that we use all the time, there's no documented way of doing MCDC for it. And so how do we go about that? And so while I've not worked on that myself personally, from what I've heard, there's a lot of like design considerations, a lot of like open discussions that happened on how do we accomplish these things in this MCDC in Rust. So yeah, it's I think still an open question on how to do it for some language constructs.
So outside of safety critical, is there anything that you really want to see to make it possible or easier to use Rust in the spaces that you're interested in?
Yeah, I mean, for me personally, I okay, I have written a lot of Python recently. So for these coding guidelines, we're sort of trying to use what might be considered like sort of state of the art for document rendering, and trying to use what's the best in breed for that. And the answer is Sphinx, and the answer is that I need to, along with the other contributors, write Python code for Sphinx extensions to do things to make these documents render very nicely. So if there's anybody listening out there that would like to write something on the level of quality and engineering effort as Sphinx, so that I can write, extensions in Rust, you have my thanks. I'd be eternally grateful.
Have you wasted any time trying to use PyO3 to write a Sphinx extension?
That sounds like a good use of my time at some point. Now is not that time. I've not investigated the time yet, or invested the time yet. But I've heard the story around, Python and Rust interop is actually quite mature and quite nice. I personally have done interop with Rust more with other languages, C, C++, and actually a bit of Java. So I haven't dipped my toe into that pond yet of Python and Rust interop. So
Yeah, I think it's probably purely for fun at this point. I don't know if writing Python is actually slowing you down from.
it's not in reality. It's it's just you sometimes wake up and you're like, time to write more Python to help Rust. So some days are like that.
Yeah, I can relate to that actually. Cool. Well, I think we're about at the time where we should wrap up. Is there anything else that you want to share?
I mean, I want to just, I don't know if I've communicated that too much, but I want to just say that the Rust project and the Rust community have been extremely welcoming, and kind of like looking from the outside in the past, I wonder what was going on in there. How are these decisions being made? You see posts on Reddit or something, you see some thing going on, and you're like, oh, some drama's going on. What's happening? But really, it's a group of people that at the end of the day are just human. They're people, but they're trying to do the best they can and are very welcoming if you want to come in and try to improve things. That's what I found is started showing up to meetings, started showing up in Zulip a little bit, and showing that you want to roll up your sleeves a little bit. if you have them on your on your shirt. And then you can get involved. So that's one thing that I've really loved about the Rust community, is really welcoming and inviting. And I hope that we are, what I say within the Safety-Critical Rust Consortium is, like, we have a high bar to meet. Like, the Rust project has done a great job of having a high bar for quality, but also for the expected ethics and morality and the interactions with others. And so I try to keep that in mind and say within the consortium that, like, we should act with empathy for the engineer that has to use these guidelines. Like, let's try to put ourselves in their shoes. So if you ever are interested in getting involved with Rust, there's lots to do. So show up and jump in.
Yeah, it's an important field. I would love to see Rust powering the cars we drive and the planes and all the other safety critical stuff, because I think it's a great match for Rust, and I appreciate that all of the leadership that you've shown and in paving the way. So I'm really glad that you felt welcome by the community and that you've been as involved as you are. Well, I think that is a great place to end. So thanks, Pete LeVasseur, for agreeing to interview and for the chat. It was a good conversation.
Cool. Yeah. Thank you.